Okay, let's imagine something for a moment. What if our power supply wasn't, dependent on the sun being up, or the wind blowing, or even fuel running out?
Like just constant, reliable power.
Exactly. Just there. Always. Today, we're doing a deep dive into an investment application from a company called Smart Life Streams, LLC.
Ah, yes, the Energy Stream project.
That's the one. They're proposing a really revolutionary platform based on magnetic force, believe it or not. Let's try and unpack what they're actually claiming here.
Right. And our mission today is really to cut through the noise, get to the core of their claims about stable, permanent energy.
And figure out what that could actually mean for you, for reliable power down the line.
Yeah, whether that's for, I don't know, a hospital needing backup, charging your car, or maybe even powering your home someday.
Okay, so we all know solar and wind are great. They're a big part of the picture now.
Huge part.
But yeah, there's that unpredictability, isn't there? That intermittency. It makes getting to 100% reliable power, well, really tricky and expensive.
Oh, absolutely. That intermittency, it forces us into really costly solutions. You're talking huge lithium-ion battery farms, right?
Yeah.
Those can run, what, $200 to $400 USD per kilowatt hour. It's significant.
Wow.
And you need these super complex smart grids just to manage the fluctuating supply and demand. All these extras can bump up the total cost of energy by like 20, maybe even 50%.
That's massive.
It is. And it leads to, estimates suggest, around $100 billion in losses every year in the U.S. alone, just from grid instability.
And that hits critical places hard, right? Like off-grid hospitals.
Exactly. Hospitals, remote communities, places that absolutely need consistent, nonstop power. They feel it the most.
Okay, so this is the problem Smart Life Streams says they can solve. With Energy Stream.
Right. Harnessing, as they put it, permanent magnetic force.
Which, let's be honest, sounds different. It definitely challenges how we usually think about generating power.
It does. Their core idea, their proprietary innovation, uses something they call tangential magnetic shearing forces.
Shearing forces.
Yeah, think of it less like magnets just snapping together or pushing apart. It's more like a continuous controlled sliding or twisting action between magnetic fields that are shaped in very specific ways.
Okay.
And the goal is to use that constant magnetic interaction to convert stored magnetic potential into a continuous flow of electricity.
Right. And the advantages they list are pretty eye-opening.
They really are. Zero fuel needed. Predictable output, 247, 365 days a year.
That's the big one.
And supposedly minimal degradation, like 0.01% loss per year.
Oh.
Plus silent operation, and it can scale from, say, tiny watt-level chargers up to multi-megawatt power plants.
Okay, that sounds amazing. But, the immediate question that pops into my head, and probably for a lot of our listeners, is magnets. Don't they, run out? Isn't it just stored energy like a battery?
That's the million-dollar question, isn't it?
Yeah.
And arguably the biggest scientific hurdle people see. This application tackles that head-on. They make a crucial distinction between force, that inherent push or pull a magnet has, and energy, which is what you get when work is done.
Okay, force versus energy.
What Smart Life Streams claims is that their method uses the constant force of the magnets to continuously move components doing work. And that work generates electricity.
Without actually using up the magnet's inherent field.
Exactly. Think about how we understand batteries they discharge. The stored chemical energy depletes. But with these magnets, specifically neodymium magnets, ND50.
You're really strong ones.
Yeah, the super strong rare earth ones. They claim the force itself is intrinsically stable. It barely diminishes. The demagnetization rate is tiny, about 0.01% per year under the right conditions.
Wow, 0.01%. So they keep their strength for a long, long time.
Decades, 50, maybe 100 years. So unlike resources that get used up, water in a dam, wind, sun, natural gas, the magnetic force is just there. The analogy they might use is like having a river that just never, ever runs dry. And they're saying they've figured out the water wheel design to constantly capture its flow. It's a fundamental shift in thinking.
That force versus energy distinction is full. It's key. But it's also where the skepticism usually kicks in, scientifically speaking. So assuming for a moment this principle works, as they say, what's the roadmap? How do they plan to actually, make this real?
Good question. Right now, they're very early stage, pre-prototype phase, basically.
Okay.
Their next step is raising capital. They're seeking $180,000.
What's that for specifically?
Primarily to build a working prototype, a small one, a 5-watt charger. That funding would also cover hiring a dedicated materials engineer, which seems pretty critical,
Makes sense.
and getting outside help for design, manufacturing, and also, importantly, finalizing their patents.
So get the proof of concept built and protected.
Exactly. The aim is to hit that milestone, show it works, and then go for Series A funding, hopefully by the second quarter of 2026.
And the long game.
The long game is scaling up significantly. They envision systems ranging from 10 to 30 megawatts, enough to power EV charging stations, maybe whole neighborhoods, even industrial sites.
Well, this deep dive definitely makes you look at magnets and fundamental forces a bit differently, doesn't it?
It certainly does. And maybe here's something for you, the listener, to think about.
Go on.
If, and it's still an if at this stage, but if a constant inherent force like magnetism can genuinely provide stable power without needing constant external input,
Yeah.
how might that change your whole idea of what renewable energy even means? And what could the ripple effects be globally? Something to ponder.